Hello viewers, in this video we are going to learn about register reference instructions, execution in an instruction cycle. Register reference instructions, for performing any of its operation, it takes only the content from accumulator or extended bit, or else both the accumulator and extended bit. And after performing the operation also, it stores the result either in extended bit or in accumulator or in both. Okay, for performing any of its operation, it never refer any of the content from memory, and after performing the operation also, it never stores any result back into the memory. Okay, this is one of the very important point about register reference instructions. Okay, let us now discuss how these register reference instructions are identified. Register reference instructions are identified when D7 output of the decoder is equal to 1 and I flip-flop value of the decoder is equal to 0. In such case, those instructions are known as register reference instructions. And during the timing signal T3, this register reference instructions execution starts, and the operation what it is going to perform, it depends on the 0 to 11 bits of the instructions. Okay. So um, let us now discuss now how these register reference instructions can be symbolically represented. The execution of the register reference instructions are symbolically indicated using the symbol R. Okay, and what operation it is going to perform also need to be symbolically represented, right? So it depends on the bit values which are present in the bit values of 0 to 11th bit of the instruction register, right? So what is the bit value set that can be represented by using the symbol B followed by that particular bit? Okay, so based on the bit values that register reference, it performs a particular operation. Okay, for example, if 11th bit of the instruction register is set during the timing signal T3, the register reference instruction, it performs the clear accumulator operation. Okay, here the binary code of all the register reference operations are specified. Here you can see the instruction, it contains in 15th bit of the instruction is 0 and 12 to 14 bit of the instructions are set to 111. That's why these are known as register reference instructions. And here you can see 15th bit of the instruction is set to 1. So in such case, during the timing signal T3, D7 will be active, I will be equal to 0. Then bit value 11 is also set to 1, right? So in such case, it will perform the operation clear accumulator. Okay. Now, when this instruction is executed, it will clear all the values in the accumulator. And when 10th bit of the instruction register is set to 1, then clear extended bit operation will be performed. In such case, extended bit value will be set to 0. And if 9th bit is set to 1, then complement accumulator operation will be performed. In such case, all the values of the accumulator will be complemented. And if 8th bit is equal to 1, then complement extended bit value. Okay, so in such case, extended bit will be complemented. Then, if 7th bit is equal to 1, then circulate write operation will be performed. Let us now discuss the circulate write operation with an illustration. Here, whenever circulate write operation is performed, all the bit values of accumulator will be shifted right one bit position. You can see here all the bit values of accumulator. Here you see this is the, just assume this is the accumulator content and extended bit content. Here all the bit values of accumulators are shifted one bit position right, and 0th bit of the accumulator is shifted one bit position right. When it is shifted, it occupies the E bit. Okay, and when E bit shift right operation is performed on E bit, it occupies the 15th bit of the accumulator. Okay, when E bit is shifted, it occupies the 15 bit of the accumulator, and 0th bit is 0th bit of the accumulator is shifted, it occupies the E bit value. Okay, if suppose 6th bit of the instruction is set to 1, then in such case, circulate left operation will be done. Very similar to the circulate right operation. Here, all the bit values of accumulators are shifted one bit position left. So when they are shifted one bit position left, then a 15th bit of the accumulator will occupy extended bit value, and extended bit value it will occupy the 0th bit of the accumulator. Okay, so when circulate left operation performs, the resultant value of the above accumulator and E bit value it will look like this. Okay. Then coming to the next instruction, if a 15th bit of the instruction is set to 1, increment accumulator operation will be done. Okay, and then this operation will be done by enabling the increment input of the accumulator register. Okay, when a fourth bit of the instruction is set to 1, then uh, the operation to be performed is skip next instruction if accumulator is positive. Okay. How can we determine accumulator is positive or not? It is based on the 15th bit of the accumulator. Usually, accumulator contains the operand values, right? Either it contains the positive value or negative value, depends on the 15th bit of its flip flop. Okay. If 15th bit of the accumulator is equal to 0, then it contains a positive positive operand. And if the 15th bit, which is also known as sign bit, right? So if it is equal to 1, then it is then the accumulator in the remaining uh, 15 bit values of accumulators are used for storing the operand, and 16th bit is used for storing the sign bit value. Okay, so if 15th bit contains 1, then in bit of the accumulator it contains negative value. Okay, so in such case, that is if B4 is set to 1, that is bit value 4 is set to 1, then the operation to be performed is if accumulator 15th bit is equal to 0, that is if it contains positive value, then skip next instruction. How the next instruction can be skipped? By incrementing the program counter value. Usually, the program counter contains the address of the next instruction to be executed, right? So, if next instruction need to be skipped, then if its value is incremented, it will skip that instruction and it will point to the next instruction in the sequence. Okay, and if bit value 3 is set to 1, the operation to be performed is skip next instruction if accumulator value is a negative. Okay, so very similar to the above. Here, if accumulator 15th bit is equal to 1, then the next instruction need to be skipped by incrementing the program counter. And if second bit of the accumulator is equal to 1, then the operation performed is skip next instruction if accumulator is a 0. Okay, so accumulator is determined as having a 0 value. If all its bit values are equal to 0, then only um, it is determined as having a 0 value in its accumulator. Okay, in such case, the next instruction need to be skipped by incrementing the program counter value. And if a first bit of the instruction is set to 1, then operation to be performed is uh, skip next instruction if E bit value equal to 0. Okay, if E equal to 0, next instruction will be skipped by incrementing the program counter. And if suppose 0th bit of the instruction is equal to 0, then halt operation need to be performed by clearing the by resetting the start stop flip flop value, and usually this is done manually only. Okay, like this, all the 12 operations of register reference instructions are performed. You can observe here all the operations are performed either with the accumulator value or else E bit value, or else both accumulator as well as E bit value. So it never refer any of the operand from accumulator, and even after performing the operation also the result never be stored into the memory. The result here in register reference instructions, after performing every operation, result is stored either in accumulator or in E bit or else in both. Okay. Students, if you find this video useful to you, kindly subscribe this channel. Thanks for watching.